Okay, so, whoops, forgot to open this thing up. We're going to start out talking about piecewise functions. So what is a piecewise function? Well, a piecewise function is a function comprised of at least two functions. Okay, they can have 2, 3, 4, they can have as many functions as they want. For you guys, when we start out doing this, we are going to just do them with 2. Okay, each function defines a different part of the function's domain. Okay, quick review on domain. Domain is the set of all the input values or x values of a function. Okay, so essentially what a piecewise function is it's one function that's made up of 2 different functions. So if you guys look up here on the left, I've got y equals. I could also say that this is f of x equals, because y and f of x are the same thing. Okay, but what I have here is I have one function that is made up of 2 different functions. Okay, and the domain decides where these 2 functions are. So x plus 1 is only going to take place where your x's are less than 0. And negative 3x minus 1 is only going to take place where your x's are greater than 0. Okay? So what I have here is I have 2 functions. One of my functions is y equals x plus 1. Now we just did a graphing review, so x plus 1, it has a y-intercept at 1. Okay, so right here it's got a y-intercept. And it's got a slope of 1, which if I want to make that a fraction would be 1 over 1. So I could go up 1 to the right 1, could also go down 1 to the left 1. Okay, so the first part of this function is this part right here. That's the first part of our function. That's the part in red. The second part of our function is that y equals negative 3x minus 1. Y equals negative 3x minus 1. Okay, so that would have a y-intercept at negative 1. Okay, and then I've got negative 3. I can put that over 1. That would go down 3 to the right 1. Okay, could also go up 3 to the left 1. Okay, so if you guys look at our picture down here, you guys can see the red, or the top part, and you guys can see the bottom, which would be the blue part. Red, blue. Okay? So, it's got pieces of those functions. It's not the whole function. This piece is the top part. This piece is the bottom part. So how do they know which is the top and how do they know which is the bottom? Well, that's where your domain comes in. Your x values are less than 0. Okay? Remember, this right here is our x-axis. So where are my x values less than 0? Well, my x values are less than 0 on this side of the graph. I'd have negative 1, negative 2, negative 3, negative 4. So anything that is on this side would be where my x values are less than 0. So notice where the x values are less than 0, that's where I have my red function. Okay? On the flip side, for this one, I've got x is greater than 0. Where are my x values greater than 0? Well, again, we're on our x-axis here. And it even says, a lot of times it will say this, guys, on your graph, hey, you got a positive 5. Is that x value greater than 0? Yeah. 4, 3, 2. All those numbers are greater than 0. So that means that on this side is where all of our x values are greater than 0. So that's why we've got our blue function on this side, because that's where my x values are greater than 0. Okay? One special point up here is going to be this 0, and this 0 is called the split point. And the reason it's called the split point is because that's where the function splits. Where x equals 0, this dashed line that I'm putting down here, that is the split point. On this side of 0, we need the red function. On this side of 0, we need the blue function. Okay? That split point is going to be important to identify when we are graphing these functions. Okay? One more thing that I want to point out to you guys is when you look at this, if you notice, the endpoints of these 2 functions are different. Notice that the red function is closed, has a closed circle, whereas my blue function has an open. Look up at the piecewise and see if you guys can identify why the red would be closed and the blue would be open. I notice that for my red function, it's closed because that is a less than or equal to. Versus my blue function is just a greater than. Okay, if you guys remember when we went over these, if it's just a greater than or less than, you have an open circle. If it is less than or equal to or greater than or equal to, you would have a closed circle. Okay, so what we're going to do, I'm going to go through and graph one of these with you guys, show you guys how I do it, and then we will have a couple of practices for you guys to try on your own. Okay, so starting out, the first thing that I do is I would graph the first function and I graph the second function. I graph the whole dang thing. Okay, so I'm going to first identify what is my first function. Well, my first function is y equals 2x minus 3. I would write these out as y equals 2x minus 3. A lot of times that helps people to see. It's just easier. It's in y equals mx plus b form. Okay, so y-intercept is at -3. My slope is a 2. Remember, that can be a 2 over 1. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I just keep this pattern going all the way through. You can do the same thing on the other side. Okay, now if you're drawing this with pencil, I'm going to tell you guys we're going to erase. So I tell the people to go ahead and graph lightly when you graph these the first time through. Okay, just so you don't get confused on what's there and what you've erased. Okay, so we graphed our first function all the way through. Check. Now we need to graph our second function. Our second function is y equals 1/2 x plus 1. Y equals 1/2 x plus 1. So we've got a y-intercept at 1. And my slope is 1 over 2. So up 1 to the right 2, 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 1 right 2. I can do the same thing, down 1 left 2, down 1 left 2. Okay, these lines are going to cross. Not a big deal. Remember, draw lightly so that we can get rid of them if we need to. Graph our second function. Okay. Next, it says to determine your split point and mark it with a dashed vertical line on your graph. Remember, our split point tells us where does this thing split. Okay, your split point is going to be the number, the number that is dealing with our domain, x less than 2, x greater than or equal to 2. So 2 is my split point. So at 2, I'm going to draw a dashed vertical line. Okay, I'm going to draw a dashed vertical line. All right, got that done. Now it says determine which side of the split point your first function should be on. Okay, so we've got two options. It can be on this side of the split point or this side of the split point. So my first function, my red function, does my red function need to be on the left or on the right? Well, I'm going to look. My red function says x is less than 2. So should the red function be on the left side of 2 or on the right side of 2? Think about the points on the graph. What points for x values are over here? -5, -6, -7, 0, -2. All of those numbers would be less than 2. So that means that we need our red function, we need 2x minus 3 on the left side over here. Okay? So I've determined that on the left side of my split point is where I need to have my red function. Now it says erase the first function so that it is only on the correct side. So I need my red function on this left side, which means I'm going to leave the red function over here, but on the right side, I'm going to erase my red function. Now, problem with computers, I got to redraw this. Okay? So I have erased it, so now the red function is only on my left side here. Okay. Number 6 says determine which side of the split point your second function should be on. Well, I will tell you guys this. If you have determined that your left side is the red side, then your blue side cannot be on the left side. Your blue has to be opposite. Once you know that one's on one side, the other one has to be on the other. But it makes sense that our blue would be on the right because our blue says that x needs to be greater than or equal to 2. Greater than or equal to 2. So if I'm looking at numbers, 4 is over here, 5, 6, 7, 8. All of those numbers are greater than 2, so my blue function would be on my right side. Then it says erase the second function so that it is only on the correct side. So I need to erase my blue so that I only see blue on the right side. So I'm going to erase this big old long thing here. Okay? And now you guys have done your done your piecewise function. The only thing I forgot is a step 8, which the step 8 is determine your endpoints. And what I mean by determine endpoints is you got to determine, is it open or is it closed? So I'm going to go up here. For my red function, I've got a less than. Less than would mean that I would need an open circle. So for my red function here, where I get to my split point, I've got to have an open circle. Versus for my blue function is greater than or equal to, which means that my blue function needs to be a closed circle. And you guys have graphed a piecewise function. Okay? If you want to try and make it look nicer, you could technically erase this green dashed line, but you don't have to. Okay? But that is a piecewise function that we have graphed. Okay? So, that took a little while to do. I'm going to go ahead and stop the video here, and if you guys want, on your own, I've got an example for you guys to try. On your own, I have an example for you guys to try. So what I would like for you to do is, before you watch the next video, I would like for you guys to do these two functions, try and graph them. Okay? And then the next video will explain how to go through and solve these ones for you guys.